Hello, everybody. Welcome. Thank you for coming. I know when we reach the afternoon, the second day of a conference, I don't know if you're like me, it's like, trying to regain that energy. So, especially with the party coming, I know DevReach is famous for the party. This is now my fourth DevReach, so I'm really excited to be back here. So, if you're here to hear about strategies for offline data and web apps, you're in the right room. So let me go over a little bit of what I'm going to talk about in this session. So we're going to talk a little bit about determining online and offline status, so whether your user is online or offline, storing simple and small amounts of data offline. Then we'll talk a little bit about trying to store more complex and large amounts of data offline. We'll talk a little bit about data synchronization strategies, and I will cover some libraries and tools that can help you do some of these things. What we aren't going to talk about, though, is while all of these things are useful for PWAs, I'm not covering PWAs, so you can take some of the stuff and use it in your PWA, but I'm not going to cover that, or service workers, or things like asset caching and the Cache API, which you would want to use if you're doing a lot of offline stuff, but this is more just about the data. So a little bit about me. I do work for Progress, which obviously puts on this event. And I actually work in the content team. And I came here all the way from Orlando, Florida. This is I took that in my backyard. This is just a common scene in Florida, as any of you who've ever been there know. We're famous for this. We're famous also for really, really, anybody ever heard of Florida Man? Has Florida Man made it here? Because Florida Man is famous in the States. We apparently, all the people whose brains have somehow disconnected from their bodily functioning have made it to Florida. That's where you go. So anyway, there's endless stories of Florida Man. Which is why, when I'm there, I usually stay inside, and I love to play games. Anybody? I don't know if this is big in the States. Anybody here play Fortnite? Yeah. Any Fortnite players? We got one Fortnite player. I guess Fortnite's not very big in Bulgaria. So in case you don't know what Fortnite is, this is what Fortnite looks like. It's just like a multiplayer game where it's called a battle royale. We have like 100 people in a room, and you got to fight. Last player to live wins, basically. And so the reason I bring that up is because it's going to play a part in a lot of my demos here and stuff like that. So let me get, okay. There we go. So basically, the reason I started looking into this topic was because I was working with a product called Convey that we have. I don't know if you've ever heard of it, but it's basically you can store data in the cloud, and you have microservices and all kinds of serverless stuff like that. And we were talking about our offline features, and they started talking about it, and there was all kinds of cool features, and I was like curious about how that actually got built. So I went ahead and I proposed a topic for a conference that I'm like, oh yeah, you know what? I'll learn that. It can't be that hard, right? Turns out that offline data is actually really big and complex topic. So I'm going to try and cover kind of all of the things you might need to get started with that, but it is a massive topic that I could literally spend days on this if we really wanted to get into it that in depth. So as I mentioned, I went ahead and built a demo app here that try some different things doing offline. So I'll show you this is what it looks like there, but I'll show you how it works. One thing I'm known for is my design skill. I can use Bootstrap really, really well. Look at that. I know you're impressed. It's a simple app. Let's hope the Wi-Fi holds up. So I can look up my stats here. Come on. Not working. Demo fail. All right. Let's try this one. See if it's already loaded. Yay! There we go. Let's see. Not working. So the Wi-Fi doesn't seem to be giving me anything back here, so I don't know why. Oh well, come on, app. All right, well, what you'd see if that worked is it would load my data from the Fortnite API out. And there's actually an API we can call. It's an amazing amount of data you can get about Fortnite. It's unbelievable. You can get people's stats and like the level of detail of the statistics that it gives you. I only showed in my sample app, which you can check out. I have the code on GitHub. But so in my sample app, I only show a small chunk of the data of what you can get about Fortnite in there. And if you saw it, you would see that I have actually a really high win ratio, which is unusual for a game. But you would also see I have a very low kill-death ratio, and it's because the only time I play Fortnite is when I play with my kids. So basically, my kids carry me the whole time. I literally suck at Fortnite. But my kids are good. So I win a lot. I just don't play very well. I don't know if this is going to, I click this, see if this is cached anyway. This is one of the offline versions, so that's why it works when your Wi-Fi is failing you. So you can pull up the store items and upcoming store items and stuff like that. Fortnite is famous for like dances and skins and all kinds of stuff like that. So that's all you can buy in these stores, and people spend, when I heard how many millions of dollars this company is making a month off this game, and all you can buy is cosmetic items that don't actually affect your gameplay, and somehow they make millions of dollars. Like people spend $20 for a skin that does nothing into the game. But, good for them. They found a way to make money off of useless things. So, anyway, that's Fortnite. So I'm going to start out talking about okay, when you land in Fortnite, the first thing you got to do is get some weapons. So I figured, the first thing I got to do in digging into, well, how would I actually go about building something that does data sync and all that stuff? The first thing I'm going to have to know is, well, are you online or are you offline? What level of data are you able to get in your application? So we're going to look at Navigator.online and Network Information API, which will be our weapon. So Navigator.online will return this online status of the browser. So it's really simple. It's just true or false. Are you online or are you offline? So I kind of compared it to you can't. I don't know how well you can see that gun. That's like a hand cannon. It's a good weapon. Doesn't do a lot, but but it's useful in particular cases. And this is how you'd use it. So basically, as I said, very easy. If Navigator Online is true, and then I'm going to load the remote data. If not, I'll load local data. Obviously, you could get more complex than that, but that's basically how it works. So very simple, and the good news is it works pretty much across all the browsers the same, so you can use it everywhere, and pretty reliable. But it doesn't give you a lot of information, so I thought, well, a lot of times it's not really about are they online or offline, right? Like, for instance, when I come here, my phone still gets data, but I only get 2G speeds and barely that because I throttle it. So you can be online but have really slow data. And I might actually want to load from the cache quickly if the data is slow or something like that. And there's actually something called the Network Information API that is supposed to give you all kinds of information about the system's connection and the speed and so on and so forth. And that sounds awesome, but I compared it to the white burst and burst AR in Fortnite because that is literally the worst weapon in Fortnite. And honestly, if you find it, you're like, I walk on by. I don't need it. Because I'll show you why I think so. So first of all, this is how it will work. I set up, obviously it's, you can see it's aliased in different browsers and stuff like that. But it's simple, just create the object, and then I look for an event on the connection status change. So this is an event-driven one, not like the other one, which is true and false. This will just change events whenever it sees a change in your online or connection status. And then so I add an event listener to that, and just right here, I'm just console logging that. Obviously, you'd want to do more. But to give you an idea of what it gives you, and why I think it's kind of useless, even on the browsers that it works on, is that here is me. At times, I'm actually completely disconnected from everything here, but like that second one, the downlink is 0, so I'm not getting any data, but it still tells me it's 4G type, and I mean, to me, this information was not useful. And that 4G, by the way, was actually me on Wi-Fi, me on hardwired. I tried out everything, and it didn't really give me any useful information in my mind. You probably could use the downlink and stuff to figure out some level of speed, but it seemed unreliable to me, and especially because it doesn't really work in anything but Chrome and Opera. So it's kind of not all that useful, unfortunately. But maybe it's something that obviously as support gets better, hopefully down the road we can use this to figure out, because I think it'd be especially useful when you're trying to decide like how much do you need to rely on the cache? Are they on Wi-Fi and they can get lots of data, or are they, do I need to kind of throttle that down and rely more on the local cache? So the first step then I said, well, okay, the first thing I'm going to do is to take this offline and store some data is use local storage. How many of you have already used local storage before? A lot of you. Okay. So this will be not new to you, but hopefully useful. I kind of compared local storage to me as like a landing on a place in Fortnite called Haunted Hills, because it's like, I mean, there's some good loot there, but generally speaking, you don't land there, but it has some usefulness, right? And local storage does have some great uses. So local storage, for those of you who haven't used it before, it's just a simple key value store. So you have a key and you put a value there, and that's it. It's that simple. And the value has to be a string. It's only limited to about 5 megabytes of total data in most cases. So that's not a lot of data, obviously. So it only can hold strings, but you can actually store, you can store JSON in there if you want. So you can put serialized data and then unserialize it and stuff. It is synchronous, but we're obviously talking about small amounts of data, so this isn't really going to be a blocking operation in most cases, but it is something to keep in mind. One of the things that, when you're using local storage is you want to make sure you're not putting anything that needs to be protected. Like, you don't want to put any user IDs and things like that might be used by somebody for nefarious purposes, because there's no data protection on local storage. So that's where you want to actually put that in a cookie or something if you need to, but not in local storage. It's really best for maintaining state in an offline app. So in my sample app that you can see there, I'll give you the link again later. In that sample app, the first version I have that does some offline is basically I store, when you enter your username, I'll store that in this case, because that's not sensitive information. I'll store that, as well as I actually get back the user data for your stats, and I'll store that in there as well. So it's really also very simple to use, given it's a simple thing. It does only something simple, but it is very easy to use. You just set the key. In this case, my key name is platform. That's the platform that you're on in my sample app, and I just store a string with the platform string. And then to get it, I just say, set a variable to get item and give it the key, and it's going to give me the value. And the same thing you would set, if you're going to serialize data and store it in local storage, you'd set it the same exact way with that set item. But in this case, I'm going to just parse the data that I get out, right? That's all. So it's very easy for that, but again, you have to keep in mind that you can only have that small amount of data, so you don't want to store a lot of stuff there. So it's not really useful for storing large complex data sets or anything like that. So if you do want to store large complex data sets, you would want to use something like IndexDB, which, let's go back to my Fortnite analogy, is like Dusty Divot. It's a pretty good place to land. It's not the greatest place to land in the Fortnite map, but it's a good place to land. And IndexDB is good. It's useful. It's a good tool. So one thing about IndexDB is it's asynchronous, which is especially important here because you can do large amounts of data, right? So it can do a lot. So you got to make sure that this isn't not going to block your UI or anything. As I said, it's optimized for storing large amounts of data. You can store complex data. If any of you have ever used a NoSQL data store of any type, you'll feel comfortable using IndexDB because that's how you store data. It's a NoSQL data store, effectively, that lives on your on the user's local machine, right? So there are large storage limits, and that's vague, yeah, because what's large? and it depends on, number one, it depends on the browser, and it depends on the user's disk space. There's like hard limits and soft limits. So there's like a soft limit in most browsers at about 20% of disk space, and a hard limit, I think, of 50% of available disk space. So again, that depends on how much available disk space your user has, which you really don't know, but it's probably a significant amount, right? We can store a lot in IndexedDB. And it's also transactional, so if you've ever used any kind of transactional database, you would understand how this works, right? So I can have a lot of different things going in and out, and the transaction prevents, like if I say the app was open twice or something like that, things from overwriting each other, so on. So using IndexedDB is relatively easy. One thing to understand is it's event-based, so it's not like, it's not promise-based or anything, so you have to listen for events and things like that. So in this case, I'm basically gonna set a variable where I'm gonna store the database when I get it back. So I'm creating one here. I'm gonna open one named FNDB, and then I have to give the version number. That's kind of important because it plays a role in some of the rest of the code. And that version number is just, I can put whatever number I want as long as it's an actual number, like a whole number, right? So version 1, version 2, version 3, so on, right? And then obviously you'd want to have better error handling than I have here, but for the sake of a demo, you listen for an error, you listen for like a success event, and in this case, the success event just says, okay, your database was created or connected to, and send me back the database, right? That I can use for anything after that point. Then another thing important here is this on upgrade needed. So as I said, that version number is important. In this case, like imagine this, in this particular example, I'm actually creating the database if you visit this page for the first time. So it's going to call on upgrade needed because it knows that it doesn't exist. And so I need to basically create version 1 of this data store. But if I were to say release a new an update to my page and I change that number to 2, it would also trigger this again. And I can actually look in that code in this on upgrade needed method and check to see what version it is. And so I can add indexes and things like that, which is an important thing that I'm not doing here. If you want to be able to query by any particular value, so let's say in my case, I want to be able to look up, I actually store all the data from the Fortnite store in there. If I want to look up items by their name, I actually have to create an index for that. Otherwise, I won't be able to search the data by that value. So you would create that in this on upgrade needed method. You don't actually have to set like, okay, there's no columns, right? So I don't have to say anything like that, but I do need to do things like create those indexes and so on. I can also create new object stores. In this case, I have 2 object stores in my sample. I only show one here. But in this case, I'm creating one for the daily store items. As I showed you in the demo, there's daily store and there's upcoming store. So I'm creating those, and I'm setting the key path, which is like the ID, right? This is basically, you need to have obviously every database needs to have an ID. In this case, the item ID is my unique key, and that's what I'm setting it to. And I would also, again, create any indexes or anything right here. It's pretty easy to add data. Again, you have to work within a transaction for anything that you do in IndexedDB. So there, I'm creating my transaction. I'm telling it, I'm going to connect to the daily store items. I'm going to read write, and then the object store within that. So here I'm just adding an item, and then also I'm putting an item as an example. Just the difference between add and put is add will always create a new one, and put will actually either create a new one if it doesn't exist, or it will update one if it finds an item with that ID in there. So generally speaking, I mean, you can just put, but there may be use cases for when you want to add instead of using put. And then getting data is pretty easy. Again, I have to create a transaction. And then in this case, I'm just doing get all. So I'm just getting everything in the data store. And then when I listen for on success, and when I get the result back, I can work with the data however I want. So pretty easy to get data. You can do querying and stuff like that. I'm not actually going to talk about the querying very much here because I'll talk about some tools that make it a little easier. Because what I found about IndexDB, while it's really great and useful and not that difficult to use, but when you start to get into more complex things with the data, that's when it started getting a little bit tougher to use. Like for instance, if you want to be able to query by multiple indexes at the same time, things like that weren't quite so simple. So I found it a little bit tough in that sense. So the next step for me would be, okay, now I've got my data store and I'm storing data in there, large amounts of data, and I want to be able to actually sync it with my, with my database that might be somewhere in the cloud or something else, right? I'm going to sync those up so that if a user goes offline and they're making changes, that those changes are pushed back, or changes happen on the server when I'm not connected, and I want to push those down to the user, right? Sounds not that hard in theory. And then I started investigating it, and it's like I compared it to landing in tilted towers in Fortnite, because if you ever land tilted towers, basically, if you're not a good player, you're dead within seconds. It's basically you land, die. And that's what trying to do syncing strategies for me, to build it yourself, is not simple. Typically, there are kind of two main forms of kind of ways you handle syncing strategies, which is last in wins, which is the most commonly used. And when I show you a bunch of these tools, that's typically what they do, is last in wins. So like even Convey, it's last in wins, which is basically, let's imagine a scenario where I go offline and I make some changes to data, but somebody else goes offline, makes changes to the same data. I connect back and my changes are pushed up. They connect back and their changes are pushed up and overwrite mine. So whoever is the last person, regardless of anything, whatever's the last change sent up for that record wins, right? So that's typically what the syncing strategies provide by default, because it's the simplest way to implement it, right? It's just, if I get an update, I write it. End of story. Same thing going back down, right? Some libraries and some other tools provide some conflict detection and resolution, which usually means, in the case of these tools, is like something you'll pass it up. If it detects a conflict, then it's actually going to mark the record somewhere identified in the database, either locally or in the wherever your database is that you're syncing with, and it's going to mark it as somehow in conflict and needing to be resolved. And then usually there's some kind of separate process which you're going to have to build yourself, which is where it gets really complicated, where you handle the conflict resolution, where somebody decides which write was the proper write to accept. Kind of like when it's the same basic concept of when you commit code to GitHub and there's a conflict with something in your code, then you have to somehow resolve this, right? So that's the basic idea there, but it's obviously not simple to implement. And then I put kind of like just ... because it's like there are 1,000 other ways to handle syncing strategies. So like imagine if you're at a company and you say like, oh, well, because this person is an admin user and that person's a regular user, the admin user's rights always supersede the regular user's rights, and so on and so forth. I mean, you might have some things like that depending on your application. So you want to implement some kind of custom syncing strategy, which obviously also gets really complicated. So when I started digging into this, I'm like, I'm clearly in over my head a little bit trying to build this myself. So I started looking at some tools that might help me get that done. And thankfully, it's JavaScript, so we write tools like, there's no tool that a JavaScript developer can't rewrite. There's no solution they can't come up with 1,000 times over. So there are a lot of them. I started with one called Dexy. You can find it at dexy.org. So one of the nice things about Dexy was that it, first of all, it takes that event-based API that IndexDB has and actually makes it promise-based, which I found a little bit easier to use and cleaned up my code a bit. And it actually allowed me to remove some chunks of code in that example. So again, when you go to the GitHub library, there will be 6 versions, so that each one is slightly different, and then one of them is an example using Dexy, so you can even compare it to the straight IndexDB version that does the same things. Another thing I really liked about Dexy was it simplified querying in a way that like you could do fairly robust querying, and I didn't have to mess with any of that behind the scenes stuff in IndexedDB of figuring that out. It does it for me. It does have some sync libraries. You have to add them in, but there's Dexy.syncable will basically announce events that say like, oh, a sync event that happens, and you then need to code what happens on those sync events. Then there's sync client and sync server, which is basically pre-built kind of thing. So they do what they sound like. Sync client will sync data from wherever your data source is down to the client, and sync server will push out to a server. I forget exactly, like to an external database, and I forget which one they rely on for that specifically, but it is built for one specifically that obviously you would have to adopt if you want to use that pre-built solution and not have to build it yourself. So to create a data store, I think this, if you remember the code from straight IndexedDB, this is a lot simpler. I cut out about 10, 15 lines of code here. So I just do a new Dexy, give it a name. This is the same thing, again, with the version numbers. So similar to in IndexedDB, I supply a version number here, and I'd update that if I release another version. Then they have kind of a short way of doing both the ID and the indexing, so that ampersand there indicates that that's my ID. And then these are both indexes, so I don't have to call that, like have a separate line of code to create those indexes each individually as I do in IndexedDB. I just create them right there. So that creating is simplified quite a bit from the straight IndexedDB code. Putting is pretty similar to using IndexedDB, and it works the same way. You know, add will always add, put will overwrite if the item exists. But then it adds something that I found very useful for my use case, which is a bulk put. So I can actually give it a bunch of data, and it'll insert all of that data at once. Whereas in IndexedDB, I actually had to get the records, loop over, and insert each one individually. In this one, I just send it all the records, and it'll add it all at once. So this is where I really felt Dexy shine, is in querying. These are fairly simple queries, but I'm saying like where the type is upcoming, and I'm telling it just ignore the case, so it could be, you know, capitalized on not capitalized. It's just as long as it equals that, and then I get the result. I turn it into an array, and I work with the results there. Here's another that I kind of shows the power of this that you can't do easily with straight IndexedDB. I mean, you can do it obviously, but you can't do it. You'd have to write quite a bit of code to do something like this. Rather than one line, it turns into like, get me the type of upcoming, and then just delete them all. Right? So I can actually I can chain of different things to these queries, which makes it really powerful to do like complex operations that you normally would have to write a lot of code to do in IndexedDB. I can even chain these queries, so I can actually query with, like, add more things to the query, like I can do multiple wheres and so on and so forth. I mean, it really allows you a lot of power to query into your IndexedDB database with a fairly simple API, in my opinion. So I highly recommend Dexy, and I think, you know, if you're interested in this stuff, I really, of all the things I'm going to cover, I think if you're just looking to do straight accessing IndexedDB and you want to avoid writing that code, Dexy, of all the things I tried, was the easiest. I can't say the same for PouchDB, unfortunately. So PouchDB, if you've ever heard of CouchDB, PouchDB is a JavaScript implementation of CouchDB, a CouchDB-like database, right, Datastore. It's intended to kind of mimic the API of CouchDB as well. So if you're already familiar with CouchDB, then you can use PouchDB and be somewhat comfortable with the API right out of the box. It does use IndexedDB by default. One thing I didn't cover is, some of you may remember there was WebSQL for a while. That was kind of the way you would store large amounts of local data. And WebSQL is basically deprecated at this point. It still functions, but it's deprecated. And so they thankfully went ahead and just removed the WebSQL adapter before it would switch back and forth, or you could specify, but now it's just IndexedDB by default. Again, the CouchDB-like API. It does have some convenience methods for syncing. In fact, if you get to that point and this is all working nicely, PouchDB is probably the easiest one for syncing. You do have to use a CouchDB-based database on the other end, so you can't just connect it to any kind of data source and it's going to sync. It has to be CouchDB, but you do have some options for what kind. Like there's some cloud-based couch providers and stuff like that that you can use that it will work with straight out of the box, as long as it's based on CouchDB, right? It's couch. But if you do have that in place, it's really easy to sync. The methods are basically work out of the box, and you can even tell it things like that you want it to be like live syncing, which is effectively like it won't give you an error when there's no connection, and it'll actually just keep trying this, and eventually when there's a connection, it'll actually push that back up and pull down any data that was changed back down, and it's set, right? So you do actually have to call the methods, but you don't have to implement any of the details, really. Another interesting thing is it supports binary attachments, so you can actually, say, store images or whatever we might want locally as well. I don't know that there's a huge use for that, but maybe you have one. So creating a local data store, again, this looks a lot like Dexy. It's simpler than IndexedDB, and here I'm just creating the index as well on the field of type. And that's all I had to do. You don't even have to necessarily specify the ID or anything here. And then similar type of API for putting things, right? Same with, they do have a bulk document insert as well, which makes it easy for pushing in large amounts of data. So querying does rely on a separate plugin that you have to add in. It's fairly powerful once you get used to it. It has kind of a different way of querying things, and so it relies a lot on like kind of shorthand ways of specifying things within almost like a JSON like scripting, and that's how you query within PouchDB. But it doesn't support the chaining of methods like the Dexy does on queries, so you can't. Some of that stuff is a little bit more complex to do if you want to do that. I also found it, honestly, this was the version of this that I spent the most time on, and for reasons I was unable to figure out, it just, sometimes it worked, sometimes it didn't, and I couldn't really explain why. And it was the querying partly that was where it was failing, where I would try and get information, and in my sample app, if the data is over a certain amount old, so I get it, and if it's like over a day old, because those store items change every day, if it's over a day old, I just clear it out as long as I'm connected, and then I pull in the new data. But this would kind of cause weird things where the data was flat out missing for reasons I could not explain. So I spent a lot of time on this one. I found it very frustrating. I talked to even some number of people that were like, oh yeah. It was a well-known issue, not that specific issue, but just that PouchDB is not always the easiest thing to use. So not the one I'd recommend, but you may have more success than me. Probably. It's not my, I'd say probably 90% of you are smarter than me, so, Anyway. Okay, so talking about Convey. This was actually, what inspired me to create this in the first place. This is a Progress product, so you can find it at progress.com/Convey. It has a MongoDB-based data store. One of the nice things, if you're using Convey, this is not like a freebie solution, though, so keep that in mind. It has a number of SDKs that support, so I could do the web-based version here for offline data, but that offline data stuff is also available in NativeScript. That offline data is available they have Java, I think, and I can't remember. There's a ton of, there's like 10 or so SDKs that cover a whole, like native mobile, NativeScript, some server-side stuff. So if whatever you need to do, for the most part, we're going to have an SDK that will do that, and it'll work the same as what I'm showing you here as well. So it includes support for local and remote data syncing. By default, it's that last in wins kind of data syncing, and then but it also specifies a way that you can have granular control. If you want to override that and do something more detailed, you can. And it does have it. What was interesting is it's optimized for large amounts of data, so it has something called Delta Sync, where I didn't test this in my sample app, but ideally it says, like, they claim you can have like tens of thousands of records, and it will basically sync things back and forth without any issues. And it's designed for really large amounts of data and syncing large amounts of data. Again, though, it's one thing to consider is this is more of an enterprise solution, so it's not like something I'm going to go use in my typical sample project on my own. So connecting to a data store in Convey, this is a little bit different, again, because we're always connecting to a cloud data store in this case, not just locally. It's just going to always cache it locally if I tell it to. So I actually have to have an app key and an app secret, so I'm initializing my Convey instance, and then an interesting thing about Convey is it always has to have what's called an active user. So in this case, I'm just kind of creating a generic, like, anonymous user. It's not typically what I'd recommend you do, but for a demo, it works. If you have like a web app, you might actually create like a web app user. That way, your data store isn't filled with thousands of anonymous users. And then to add the data, in this case, one of the key things here is that I'm telling it it's a data store type of sync, because that tells it that we want to be able to cache stuff locally and sync between the cloud and my local data store. And then I'm going to just save an item. It's a little bit more verbose than, say, the other examples like Dexy, but we're doing a lot more here. And then there's a sync method that will tell me, like, basically I call it, and that manages whether moving anything from local to remote or anything from remote to local. All those changes get synced automatically. Pretty easy to do. And then one thing that was kind of a pain is there's no bulk saving, but you can do a bulk delete. So I can't send a whole bunch of data. I need to actually insert every record independently, but I can remove a whole bulk amount of data all at once. Querying items querying in Convey is pretty powerful, and it's just a little bit different syntax than we had in the other stuff with straight IndexedDB. I do actually need to create a query object, and this can get much more complex than what I have here. I can add all different other kinds of things to it to make a more complex query than what I have there, and then just send that off, and it'll pass me back the data that I need to work with. So actually, if you want to see the sample app, and hopefully if you want to try it out, and if you look up remote synth _PS, you can see how bad I am at Fortnite if you're curious about that. But that's where the sample app is, at github.com/remote_synth/offline data. And then one thing I want to point out, there's actually an article going offline with NativeScript and Convey. So like some of those things, same things I was talking about in Convey, this article shows that all that works straight in NativeScript as well. For any of you who are interested in NativeScript or already doing NativeScript, that's something to look at. There are a number of other implementations. I said in JavaScript, there's nothing we can't create 1,000 times. So there are a lot of other libraries that will also help you do IndexedDB and store offline data and do data syncing. One of the ones I want to mention was ZangoDB. If you're more familiar, I know I covered PouchDB, which is like a couch-based API and library. ZangoDB actually is more a Mongo-based API, so if you're more familiar with Mongo, you might be more comfortable with that. And it looks pretty good as well. That's one of the more recommended solutions. Another one here is I want to talk about just briefly is called Workbox Background Sync. So Workbox is one of these. It's this tool set that Google's made available. A lot of times you'll see it related to PWAs, and it does actually have something called background sync if you're specifically interested in the syncing part of offline data, which was one of the things, again, that inspired me to kind of dig into this. but it doesn't implement anything. It really is more about letting you know when something needs, like there's a syncing event that needs to happen, and you handle the implementation of that at that point. So it just provides kind of some convenience ways of notifying you that a sync needs to happen effectively. And it will also do polling. It'll kind of, you can set it to continuously retry something for a certain amount of time. So like if you go offline, you can set it like within a certain time period, I'll keep retrying that and maybe pass that back up. So I think, might have ended a little bit early, but if you have any questions, I'm happy to answer them here. You can also find me on Twitter at RemoteSynth, or you can feel free to just email me and tell me, ask me any questions or tell me you thought the presentation was great or it sucked or whatever you feel like. Brian.Rinaldi@progress.com. With that, I think we have some time. Anybody have any questions? How many Fortnite wins do I have? I cannot remember, and I wish the app worked because I could show you. I can tell you I have one solo win. One solo win. Yay. It's like the only time, one of the few times I played solo. And the funny thing about it, I fired one bullet in the entire game, and that killed the last guy. I hadn't seen anybody until then. So I'm like, that's it. I retire from solo. I'm never playing again. So anyway, if anybody else plays Fortnite, feel free to grab me and talk about Fortnite as well. Thank you.